Today's lesson is on Boyle's gas. Today's lesson is on Boyle's gas law. But first, who was Boyle? Let's dive right in.
We know
Cleric, the science cleric. Cleric, the science cleric. Cleric, the science cleric.
Gases have multiple properties. Some of these properties include temperature, gas pressure, and volume.
In the mid-1600s, Robert Boyle studied the connection between volume and pressure. He studied that the product of pressure and volume are constant and inverse in a relationship.
Now, the relationship between pressure and volume is called Boyle's law, and this is mainly because of his interests and studies into this relationship. This is the equation that he was essentially found to be true, which is initial volume times initial pressure is equal to final volume and final pressure.
This relationship is what's called inverse. It's proportional, but it's inversely proportional, which means as pressure goes up, volume will go down. And if volume goes up, pressure will go down. The kinetic molecular theory states that the molecules of a gas are in constant random motion, and the pressure of the gas is caused by collisions with the outside container. Gas molecules exert no force unless they collide. Collisions with molecules and the container they're in is what causes pressure. As the volume decreases in a container and more molecules inside that area to collide, because pressure is really just the concentration of molecules within a volume. We also know from the molecular theory that molecules are points of mass. They don't necessarily have a volume. We measure their volume by the amount of space they take up. So when we're decreasing the volume, we're not actually decreasing the actual volume, we're decreasing the amount of space they take up, which causes more collisions and more pressure. And vice versa, if we increase the volume, there'll be less molecules for the same amount of area, which will cause less pressure.
Alright, so let's look at an example of this in action. So this is essentially a recreation of a pressure chamber. So as you can see, as I pull back from this, the balloon inside expands. Why is this happening? Well, let's look at that in depth.
inside a lower pressure environment, a balloon will expand. This is because by volume the gas is taking up, there's less molecules in the outside air, that the molecules inside the balloon are able to expand to equalize with the molecules outside of the balloon. The balloon expanding shows us that there's a lower pressure inside the tube when we pull the volume up. So in essence, we have demonstrated Boyle's law by increasing the volume so that the pressure decreases, which causes the balloon to expand. And if we decrease the volume, the pressure will increase and the balloon will deflate.